Okay, today we're going to talk about slope and similar triangles. So we know that the slope is the rise over the run, which is the vertical change over the horizontal change. And we write that as the change in y over the change in x. Okay? So we're going to talk about these two different triangles that we're going to draw on our first graph. So to get from A to B, so here's point A to B. So we are going to make a triangle. So to get from A to B, how many spaces up? That would be 1, 2. And how many across? 1, 2, 3. Remember, we're jumping the box. So that would be 2 over 3. So you move 2 units up and 3 units to the right. 2 over 3. Okay? The change in y over the change in x. I want you to always write that down. All right, so now we're going to go from B to C. So I'm going to go up from B to C. So I'm going to count up for B, 1, 2, 3, 4. And I'm going to count 1, 2, 3, 4, 5, 6. Okay, so now this is going to be, you move 4 units up and 6 units to the right. So this slope is 4 over 6. But that can be simplified. So to simplify that, it would become 2 over 3. Change in y over the change in x. So what can you say about these two triangles? They're not the same size. They're two different size triangles, but they have the same slope. So similar triangles have the same slope. Okay, similar triangles have the same slope. All right, let's do the next one together. They want you to connect L to M. Okay, so we're going to go up and over to M. L to M. How many up? 1, 2, 3, 4, 5, 6. And how many across? 1, 2. And it's positive, so we're moving 6 to the right, 6 up and 2 to the right. So that would be 6 over 2, which is equal to 3. And I'm going to put the change in y over the change in x here. Okay, the next one is J to K. So J to K is on the bottom. So we're going to come up J and over to K. So how many am I moving up? 1, 2, 3. And I'm moving over 1. So I'm moving up 3 and over 1 unit. Change in y over the change in x. 3 over 1 is equal to 3. Therefore, they are similar triangles. Okay, they are similar triangles because they have the same slope. Okay, they're different sizes. Remember, similar shapes have the same shape, but they're different sizes. So therefore, they have to have the same slope when drawn on a line, the triangles. Okay, then the last example, we should notice that this line is different than the other two. You can see that it starts on the left side of the graph, and it's higher on the left side and lower on the right side. That means that it's going to be a negative slope. Okay, it's a negative slope. So the first is to connect R to S. So here's R, and I'm going to go over to S. R to S. Now I'm counting down. 1, 2, 3, 4. So it's going to be a negative 4 and over 2. 1, 2. So from R to S, you move how many units down? We moved 4 down. How many units to the right? we moved 2 to the right. Again, I want you to write change in y over the change in x. Negative 4 over 2. That's going to equal negative 2. So your slope here is going to be negative 2. The last one is q to t. So q to t, we're going all the way down. So we're going to go all the way down to t. We're going to count 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be a negative 8. Across 1, 2, 3, 4. 4. So we're going to count, move down 8 and 4 across. Change in y over change in x is going to be negative 8 because we counted down over 4. And that's going to equal negative 2. So they are also similar triangles.